Returning again, Michael Dickerson, KC9PHK, here on behalf of the Clay County Area Amateur Radio Club. Here we are going to cover the 2015 to 2019 General Class Question Pool. This is Section 5 of approximately 8 videos. This video starts out with Section G4C, Interference with Consumer Electronics, as well as Grounding and DSP. First off, G4C01, which of the following might be useful in reducing RF interference to audio frequency devices? A. Bypass inductor. B. Bypass capacitor. C. Forward biased diode. Or D. Reverse biased diode. The correct answer here is B. Bypass capacitor. G4C02, which of the following could be a cause of interference covering a wide range of frequencies? A. Not using a balun or line isolator to feed balanced antennas. B. Lack of rectification of the transmitter's signal in power conductors. C. Arcing at a poor electrical connection. Or D. Using a balun to feed an unbalanced antenna. The correct answer here is C. Arcing at a poor electrical connection. G4C03, what sound is heard from an audio device or telephone if there is interference from a nearby single sideband phone transmitter? A steady hum whenever the transmitter is on the air. B. On and off humming or clicking. C. Distorted speech. Or D. Clearly audible speech. Correct answer is C. Distorted speech. G4C04, what is the effect on an audio device or telephone system if there is interference from a nearby CW transmitter? A. On and off humming or clicking. B. A CW signal at a nearly pure audio frequency. C. A chirpy CW signal. Or D. Severely distorted audio. Correct answer is A. On and off humming or clicking. G4C05, what might be the problem if you receive an RF burn when touching your equipment while transmitting on an HF band, assuming the equipment is connected to a ground rod? A. Flat braid rather than round wire has been used for the ground wire. B. Insulated wire has been used for the ground wire. C. The ground rod is resonant. Or D. The ground wire has high impedance on that frequency. The correct answer is D. The ground wire has high impedance on that frequency. G4C06, what effect can be caused by a resonant ground connection? A. Overheating of ground straps. B. Corrosion of the ground rod. C. High RF voltages on the enclosures of station equipment. Or D. A ground loop. Correct answer here is C. High RF voltages on the enclosures of station equipment. G4C07, what is one good way to avoid unwanted effects of stray RF energy in an amateur station? A. Connect all equipment grounds together. B. Install an RF filter in series with the ground wire. C. Use a ground loop for best connectivity. Or D. Install a few ferrite beads on the ground wire where it connects to your station. Correct answer is A. Connect all equipment grounds together. G4C08, which of the following would reduce RF interference caused by common mode current on an audio cable? A. Placing a ferrite chalk around the cable. B. Adding series capacitors to the conductors. C. Adding shunt inductors to the conductors. Or D. Adding an additional insulating jacket to the cable. The best answer here is A. Placing ferrite chalk around the cable. G4C09, how can a ground loop be avoided? A. Connect all ground connectors in series. B. Connect the AC neutral conductor to the ground wire. C. Avoid using lock washers and star washers when making ground connections. Or D. Connect all ground connectors at a single point. And the correct answer is D. Connect all the ground connectors at a single point. G4C10. What could be a symptom of a ground loop somewhere in your station? A. You receive reports of hum on your station's transmitted signal. B. The SWR reading for one or more antennas is suddenly very high. C. An item of station equipment starts to draw excessive amounts of current. Or D. You receive reports of harmonic interference from your station. Correct answer is A. You receive reports of hum on your station's transmitted signal. G4C11. Which of the following is a function of a digital signal processor? A. To provide adequate grounding. B. To remove noise from received signals. C. To increase antenna gain. Or D. To increase antenna bandwidth. Correct answer is B. To remove noise from received signals. G4C12. Which of the following is an advantage of a receiver DSP IF filter as compared to an analog filter? A. A wide range of filter bandwidths and shapes can be created. B. Fewer digital components are required. C. Mixing products are greatly reduced. Or D. The DSP filter is much more effective at VHF frequencies. Correct answer here is A. A wide range of filter bandwidths and shapes can be created. G4C13. Which of the following can perform automatic notching of interfering carriers? A. Bandpass tuning. B. A digital signal processor DSP filter. C. Balanced mixing. Or D. A noise limiter. Correct answer here is B. A digital signal processor, also known as DSP filter. Continuing on, G4D, covering speech processors, S meters, sideband operation, near band edges. First question here, G4D01. What is the purpose of a speech processor as used in a modern transceiver? A. Increase the intelligibility of transmitted phone signals during poor conditions. B. Increase transmitter base response for more natural sounding SSB signals. C. Prevent distortion of voice signals. Or D. Decrease high frequency voice output to prevent out of band operation. Correct answer here is A. Increase the intelligibility of transmitted phone signals during poor conditions. G4D02. Which of the following describes how a speech processor affects a transmitted single sideband phone signal? A. It increases peak power. B. It increases average power. C. It reduces harmonic distortion. Or D. It reduces intermodulation distortion. Correct answer B. It increases average power. G4D03. Which of the following can be the result of an incorrectly adjusted speech processor? A. Distorted speech. B. Splatter. C. Excessive background pickup. Or D. All of these choices are correct. Correct answer is D. All of these choices are correct. G4D04. What does an S meter measure? A. Conductance. B. Impedance. C. Received signal strength. Or D. Transmitter power output. Correct answer C. Received signal strength. G4D05. How does a signal that reads 20 dB over S9 compare to one that reads S9 on a receiver, assuming a properly calibrated S meter? A. It is 10 times less powerful. B. It is 20 times less powerful. C. It is 20 times more powerful. D. It is 100 times more powerful. Correct answer is D. It is 100 times more powerful. G4D06. Where is an S meter found? A. In a receiver. B. In an SWR bridge. C. In a transmitter. Or D. In a conductance bridge. Correct answer is A. In a receiver. G4D07. How much must the power output of a transmitter be raised to change the S meter reading on a distant receiver from S8 to S9? A. Approximately 1.5 times. B. Approximately 2 times. C. Approximately 4 times. Or D. Approximately 8 times. Correct answer is C. Approximately 4 times. G4D08. what frequency range is occupied by a 3 kHz lower sideband signal when the displayed carrier frequency is set to 7.178 MHz? Answer A is 7.178 to 7.181 MHz. B, 7.178 to 7.184 MHz. C, 7.175 to 7.178 MHz. Or D, 7.1765 to 7.1795 MHz. Correct answer in this situation is C, 7.175 to 7.178 MHz. G4D09, what frequency range is occupied by a 3 kHz upper sideband signal when the displayed carrier frequency is set to 14.347 MHz? A, 14.347 to 14.647 MHz. B, 14.347 to 14.350 MHz. C, 14.344 MHz to 14.347 MHz. Or D, 14.3455 to 14.3485 MHz. And the correct answer is B, 14.347 MHz to 14.350 MHz. G4D10, how close to the lower edge of the 40 meter general class phone segment should your displayed carrier frequency be when using 3 kHz wide lower sideband? A, at least 3 kHz above the edge of the segment. B, at least 3 kHz below the edge of the segment. C, your displayed carrier may be set at the edge of the segment. Or D, at least 1 kHz above the edge of the segment. Correct answer is A, at least 3 kHz above the edge of the segment. G4D11, how close to the upper edge of the 20 meter general class band should your displayed carrier frequency be when using 3 kHz wide USB? A, at least 3 kHz above the edge of the band. B, at least 3 kHz below the edge of the band. C, your displayed carrier frequency may be set on the edge of the band. Or D, at least 1 kHz below the edge of the segment. Correct answer here is B, at least 3 kHz below the edge of the band. G4E, HF mobile radio installations, emergency and battery powered operations. G4E01, what is the purpose of a capacitance hat on a mobile antenna? A, to increase the power handling capacity of a whip antenna. B, to allow automatic band changing. C, to electrically lengthen a physically short antenna. Or D, to allow remote tuning. Correct answer here is C, to electrically lengthen a physically short antenna. G4E02, what is the purpose of a corona ball on an HF mobile antenna? A, to narrow the operating bandwidth of an antenna. B, to increase the Q of the antenna. C, to reduce the chance of damage if the antenna should strike an object. Or D, to reduce high voltage discharge from the tip of the antenna. And the correct answer is D, to reduce high voltage discharge from the tip of the antenna. G4E03, which of the following direct fused power connections would be best for a 100 watt HF mobile installation? A, to the battery using heavy gauge wire. B, to the alternator or generator using heavy gauge wire. C, to the battery using resistor wire. Or D, to the alternator or generator using resistor wire. The best installation is A, to the battery using heavy gauge wire. G4E04, why is it best not to draw the DC power for a 100 watt HF transceiver from the vehicle's auxiliary power socket, also called your cigarette lighter plug? A, the socket is not wired with an RF shielded power cable. B, the socket's wiring may be inadequate for the current drawn by the transceiver. C, the DC polarity of the socket is reversed from the polarity of modern HF transceivers, or D, drawing more than 50 watts from this socket could cause the engine to overheat. And the correct answer is B, the socket's wiring may be inadequate for the current drawn by the transceiver. G4E05, which of the following most limits the effectiveness of an HF mobile transceiver operating in the 75 meter band? A, picket fencing signal variation. B, the wire gauge of the DC power line to the transceiver. C, the antenna system. Or D, FCC rules prohibit mobile output power on the 75 meter band. The correct answer here is C, the antenna system. G4E06, what is one disadvantage of using a shortened mobile antenna as opposed to a full-sized antenna? A, short antennas are more likely to cause distortion of transmitted signals. B, short antennas can only receive circularly polarized signals. C, operating bandwidth may be very limited. Or D, harmonic radiation can increase. Correct answer here is C, operating bandwidth may be very limited. G4E07, which of the following may cause interference to be heard in the receiver of an HF radio installed in a recent model vehicle? A, the battery charging system. B, the fuel delivery system. C, the vehicle control computer. Or D, all of these choices are correct. And the correct answer here is D, all of these choices are correct. G4E08, what is the name of the process by which sunlight is changed directly into electricity? A, photovoltaic conversion. B, photon emission. C, photosynthesis. Or D, photon decomposition. Correct answer here is A, photovoltaic conversion. What is the approximate open circuit voltage from a fully illuminated silicon photovoltaic cell? A, 0.02 VDC. B, 0.5 VDC. C, 0.2 VDC. Or D, 1.38 VDC. Correct answer is B, 0.5 VDC. G4E10, what is the reason that a series diode is connected between a solar panel and storage battery that is being charged by the panel? A, the diode serves to regulate the charging voltage to prevent overcharge. B, the diode prevents self-discharge of the battery through the panel during times of low or no illumination. C, the diode limits the current flowing from the panel to a safe value. Or D, the diode greatly increases the efficiency during times of high illumination. And the correct answer is B, the diode prevents self-discharging of the battery through the panel during times of low or no illumination. G4E11, which of the following is a disadvantage of using wind as a primary source of power for an emergency station? A, the conversion efficiency from mechanical energy to electrical energy is less than 2%. B, the voltage and current ratings of such systems are not compatible with amateur equipment. C, a large energy storage system is needed to supply power when wind is not blowing. Or D, all of these choices are correct. And the correct answer is C, a large energy storage system is needed to supply power when the wind is not blowing. Continuing on, now going to subelement G5, electrical principles. 3 exam questions come from the 3 groups. First off, G5A, covering reactance, inductance, capacitance, impedance, and impedance matching. G5A01, what is impedance? A, electrical charge stored by a capacitor. B, the inverse of resistance. C, the opposition to the flow of current in an AC circuit. Or D, the force of repulsion between 2 similar electric fields. Correct answer is C, the opposition of flow of current in an AC circuit. G5A02, what is reactance? A, opposition to the flow of direct current caused by resistance. B, opposition to the flow of alternating current caused by capacitance or inductance. C, a property of ideal resistors in AC circuits. Or D, a large spark produced at switch contacts when an inductor is de-energized. Correct answer here is B. Opposition of flow of alternating current caused by capacitance or inductance. G5A03. Which of the following causes opposition to the flow of alternating current in an inductor? A. Conductance, B. Reluctance, C. Admittance, or D. Reactance. Correct answer is D. Reactance. G5A04. Which of the following causes opposition to the flow of alternating current in a capacitor? A. Conductance, B. Reluctance, C. Reactance, or D. Admittance. Correct answer here is C. Reactance. G5A05. How does an inductor react to AC? A. As the frequency of the applied AC increases, the reactance decreases. B. As the amplitude of the applied AC increases, the reactance increases. C. As the amplitude of the applied AC increases, the reactance decreases. Or D. As the frequency of the applied AC increases, the reactance increases. And the correct answer, D. As the frequency of the applied AC increases, the reactance increases. G5A06. How does a capacitor react to AC? A. As the frequency of the applied AC increases, the reactance decreases. B. As the frequency of the applied AC increases, the reactance increases. C. As the amplitude of the applied AC increases, the reactance increases. Or D. As the amplitude of the applied AC increases, the reactance decreases. A. As the frequency of the applied AC increases, the reactance decreases. G5A07. What happens when the impedance of an electrical load is equal to the output impedance of a power source, assuming both impedances are resistive? A. The source delivers minimum power to the load. B. The electrical load is shorted. C. No current can flow through the circuit. Or D. The source can deliver maximum power to the load. Correct answer, D. The source can deliver maximum power to the load. G5A08. Why is impedance matching important? A. So the source can deliver maximum power to the load. B. So the load will draw minimum power from the source. C. To ensure that there is less resistance than reactance in the circuit. Or D. To ensure that resistance and reactance in the circuit are equal. A. So the source can deliver maximum power to the load. G5A09. What unit is used to measure reactance? A. Farad, B. Ohm, C. Ampere, or D. Siemens. B. Ohm. G5A10. What unit is used to measure impedance? A. Volt, B. Ohm, C. Ampere, or D. Watt. Correct answer, B. Ohm. G5A11. Which of the following describes one method of impedance matching between two AC circuits? A. Insert an LC network between two circuits. B. Reduce the power output of the first circuit. C. Increase the power output of the first circuit. Or D. Insert a circulator between the two circuits. Correct answer, A. Insert an LC network between the two circuits. G5A12. What is one reason to use an impedance matching transformer? A. To minimize transmitter power output. B. To maximize the transfer of power. C. To reduce power supply ripple. Or D. To minimize radiation resistance. Correct answer, B. To maximize the transfer of power. G5A13. Which of the following devices can be used for impedance matching at radio frequencies? A. Transformer. B. A pi network. C. A length of transmission line. Or D. All of these choices are correct. Correct answer is D. All of these choices are correct. On to G5B, covering the decibel, current and voltage dividers, electrical power calculations, sine wave, root mean square values, and PEP calculations. G5B01. What dB change represents a 2 times increase or decrease in power? A. Approximately 2 dB. B. Approximately 3 dB. C. Approximately 6 dB. Or D. Approximately 12 dB. Correct answer here is B. Approximately 3 dB. G5B02, how does the total current relate to individual currents in each branch of a purely resistive parallel circuit? A. It equals the average of each branch current. B. It decreases as more parallel branches are added to the circuit. C. It equals the sum of the currents through each branch. Or D. It is the sum of the reciprocal of each individual voltage drop. Correct answer C. It equals the sum of the currents through each branch. G5B03. How many watts of electrical power are used if 400 VDC is supplied to an 800 ohm load? A. 0.5 watts. B. 200 watts. C. 400 watts. Or D. 3200 watts. Correct answer here is B. 200 watts. G5B04. How many watts of electrical power are used by a 12 volt DC light bulb that draws 0.2 amperes? A. 2.4 watts. B. 24 watts. C. 6 watts. Or D. 60 watts. Correct answer is A. 2.4 watts. G5B05. How many watts are dissipated when a current of 7.0 milliamperes flows through 1.25 kiloohms resistance? A. Approximately 61 milliwatts. B. Approximately 61 watts. C. Approximately 11 milliwatts. Or D. Approximately 11 watts. Correct answer here is A. Approximately 61 milliwatts. G5B06. What is the output PEP from a transmitter if the oscilloscope measures 200 watts peak to peak across a 50 ohm dummy load connected to the transmitter output? A. 1.4 watts. B. 100 watts. C. 353.5 watts. Or D. 400 watts. Correct answer is B. 100 watts. G5B07. What value of an AC signal produces the same power dissipation in a resistor as a DC voltage of the same value? A. The peak-to-peak value. B. The peak value. C. The RMS value. Or D. The reciprocal of the RMS value. Correct answer is C. The RMS value. G5B09. What is the RMS voltage of a sine wave with a value of 17 volts peak? A. 8.5 volts. B. 12 volts. C. 24 volts. Or D. 34 volts. Correct answer is B. 12 volts. G5B10. What percentage of power loss would result from a transmission line loss of 1 dB? A. 10.9%. B. 12.2%. C. 20.5%. Or D. 25.9%. Correct answer here is 20.5%. G5B11. What is the ratio of peak envelope power to average power for an unmodulated carrier? A. 0.707. B. 1.00. C. 1.414. Or D. 2.00. Correct answer here is B. 1.00. G5B12. What would the RMS voltage across a 50 ohm dummy load dissipating 1200 watts be? A. 173 volts. B. 245 volts. C. 346 volts. Or D. 692 volts. Correct answer B. 245 volts. G5B13. What is the output PEP of an unmodulated carrier if an average reading wattmeter connected to the transmitter output indicates 1060 watts? A. 530 watts. B. 1060 watts. C. 1500 watts. Or D. 2120 watts. Correct answer B. 1060 watts. G5B14. What is the output PEP from a transmitter if an oscilloscope measured 500 volts peak to peak across a 50 ohm resistive load connected to the transmitter output? A. 8.75 watts. B. 625 watts. C, 2500 watts, or D, 5000 watts? Correct answer B, 625 watts.